actually pretty fun to play in the rain.
This problem says a 5 kg squid initially at rest ejects 0.25 kg of fluid with a velocity of 10 meters per second. What is the recoil velocity of the squid if the ejection is done in 0.1 second and there's a 5 Newton frictional force opposing the squid's movement?
I said okay.
So recoil velocity of the squid, okay. So here's the squid with ink in it, and its initial momentum is 0, it's at rest. And it squirts squirts ink, and the squid recoils in that direction. The ink is squirted in this direction. This is the force that the squid exerts on the ink and the force that the ink exerts on the squid. And then there's friction force in that direction on the squid. So the impulse on the squid, okay, so this is the force on the ink, and the force on the squid is equal to force on the ink. Force on the ink times force on the ink times the time. That impulse on the ink is change in momentum of the ink, and so force on the ink is change in momentum of the ink divided by delta T. So force on the ink is, okay, the momentum of the ink is 0.25 kgs times 10 meters per second minus 0. The ink initially was at rest, and all this happened over a span of 0.1 second. Okay, so this is equal to 2.5 times 10, which is 25 newtons. So the force on the squid, the recoil force is 25 newtons, except that now we have to subtract friction force. So the net force on the squid is 25 newtons minus 5 newtons equal to 20 newtons. Okay, so for the squid, the net impulse is 20 newtons times 0.1 second, and that's 2 Newton seconds. And let's add a page here. And so the impulse on the squid, which is 2 Newton second, should equal final momentum of the squid minus initial momentum of the squid, and that's 0. Oh, by the way, this had a negative sign. This net force on the squid is in that direction, so we calculated the magnitude, but so this is negative then. Okay, all right, so 2 Newton second is equal to m mass of the squid v final. V final is minus 2 Newton seconds, and mass of the squid was 5 kgs. Okay, so minus 0.4 meters per second. So that's the recoil velocity of the squid. and let's say and how much energy is lost to work against friction. So the ejection is done over 1.1 second, and we'll calculate the work done, energy lost in that time. So that's part B. Okay. Okay, well, here's another way to do it. All right, so had the final velocity of the squid without friction. So here's how we'll do this problem. Okay, without friction, the force on the squid is 25 newtons. And the velocity of the squid would be okay, the velocity of the squid would have been, Fs times delta t would have been final momentum. Final velocity would have been Fs delta t divided by mass, which would have been 25 newtons times 0.1 second divided by 5 kg, 0.5 meters per second. Okay, but and it's okay. This would be, this is negative and so negative. So with friction, the squid is recoiling at 0.4 meters per second. Without friction, it would have recoiled at 0.5 meters per second. Okay, so because of friction, it lost this much kinetic energy. So let's calculate that. So work done by friction is final kinetic energy minus initial kinetic energy with the kinetic energy with and without friction. So 1/2 mass of the squid times 0.4 meters per second minus 1/2 mass of the squid times 0.5 meters per second. Okay. So this works out to into 5 minus 0.23 joules. So that's how much work friction did. Okay, that finishes that problem.